Yeah, let's make a copy. Yep. What is the S20? Yeah. If Sn is n squared, yeah, 400. So let me explain a little. So arithmetic sequence means, if the common difference is 2, if we set the arithmetic sequence an is equal to this 2n plus a is a kind of the constant. We can the first term is in this case is a plus 2 when n is 1, and then from an to Sn, if we want to make the sum, uh, we can make this a sigma uh, sign. So I mean, if we multiply a n times, Sn is an, and if we add from 1 to n, the sum is like the n times n plus 1 divided by 2. So that's why 2n, when the sum of this 2n becomes n times n plus 1. So if we make the equation for Sn, we can change this n to 3n. So now n becomes 3n. And then if we divide S3n by Sn, when you cancel n, the oh, something is not right here. Actually, it become opposite. So, and then it says it does not depend on n. That means n should cancel. So if n cancel, the quotient in this case is 9 because 9n divided n is 9. And that means uh, the other terms should disappear from numerator and denominator. So that means if a becomes minus 1, they can cancel like this. And here the 3a plus 3a is also 0. So to make the quotient 9, the value of a should be minus 1. So if a is minus 1, we can use the value minus 1. So now Sn is minus n plus the n times n plus 1. So when we open the parenthesis, it becomes n squared. So now S20 is 20 squared. Yeah, number 16. I think you can solve this. Yep. You mean the bottom 3 and 4? Or bottom 4? Yeah. Uh, because, how can I say? Mm, that's because actually these two triangles are congruent because the hypotenuse is the same because the oblique quadrilateral is a square. And so this is 5, this is 5, and then so it's like these two are complementary, and because they are right triangle, like this. So it's like the yeah ASA congruence. Hmm hmm So subtract this. Yeah, yeah. You're right. So the answer is from the choices. The answer is you're right. Your answer is right. So that means find the choice. Yep, D is the answer. Yep. Yeah, number 17. So the I mean, in the case of A, we can change this the t to 2 to the 606th power to the 4 to the 303rd power, third power, and we can make this type of vector. So that means A is a multiple of 3, and B is a multiple of 3, D is a multiple of 3, E is a multiple of 5. But in the case of C, we cannot make this type of we can try this type of operation, but it becomes 2 minus 1. 2 minus 1 is 1, so we cannot make this prime number factorization. So the answer is C. Yeah, let's go to number 18. Now it becomes harder. Yeah, so let me explain this. So, here, this system has a solution other than this 0, 0, and 0. That means actually it has infinitely many solutions. So to have infinitely many solutions, so here the m1 is the coefficient of the first row, the a1, b1, c1, and m2 is the coefficient of the second equation, and m3 is the coefficient of the third equation. So if all the coefficient is the same, naturally there will be the infinitely many solutions. So because the coefficient can be either 0 or 1, we have two choices, and it has the three column, so it's like the 2 cubed. So the number of case for this case is 8. And the second case is the when two equations are the same, when they have the same coefficient, still it has the infinitely many solutions. But in this case, uh, the third equation should have the different coefficient because uh, we want to be exclusive uh, to 1 and 1. So to have the same coefficient between 1 and 2, m1 and m2, the choice for first coefficient is 8, once again 8, but the second coefficient, second set of a coefficient should be different from the first set, so that's why we subtract 1. So the second choice is 7, and then I mean there are three cases. I mean M3 is different from M1 and M2, or the M2 is different from M1 and M3, or the M1 is different from M2 and M3. So that's why we are multiplying 3 here. So for the second case is 168. And the third case is if uh, any any row contains all the zero coefficient, uh, it can have more than one solution, the other than this all the zeros. Uh, so this means because M1 choose this one particular the set of a coefficient, for M2 it has the 7 choices. So A minus 1 is 7, and for M3 uh, one less, so 7 minus 1 is 6. And then once again it can be M1 is 0, 0, 0, or M2 is 0, 0, 0, or M3 is 0, 0, 0. So that's why I'm multiplying 3 here. So the case here is 126. And the fourth case is if we add the first two equations, and if that's the same as the third equation, uh, and that means it's overlapping. The planes are overlapping in a plane, so it has the infinitely many solutions. So the first case is, let's say the first row coefficient is 1, 0, 0, and in such case the second coefficient should be uh, one of these three cases, and the sum of these will make the coefficient for the third equation. So there are three cases for M2, and then on the for M1 it can be either 1, 0, 0, or 0, 1, 0, or 0, 0, 1. So that's why we are multiplying 3 here, and then uh, it's like M1 plus M2 is equal to M3, or the M2 plus M3 is equal to M1, or the M1 plus M3 is equal to M2. So we are counting these three cases. So that's why we are multiplying 3 again. So the case for this is 27, or the first set of a coefficient contains 2 1 and 1 0. The second set should be 0 0 1, because we cannot make 1 here because 1 plus 1 becomes 2, and 2 cannot be the coefficient of M3. So that's why if M1 contains 1, M2 should be 0. So in this case, the M1 and M2's a set, so the case is 1, and then this 0 can move. So M1 can be 1 1 0 or 1 0 1 or 0 1 1. So that's why there are 3 cases here. And once again, the M1 plus M2 is equal to M3, or M2 plus M3 is equal to M1, or M1 plus M3 is equal to M2. So that's why we are multiplying 3 here, so 9. So there are all possible cases. So sum of these make the 338. So the answer is B. Yep, so I think we can stop here. So let's continue this next week, and let's meet. Do you have a time this Sunday? Is Sunday okay for you? I mean, this Sunday, Lunar New Year. You're right. Yep. So, yeah, I'll ask your mom. So, if possible, let's meet on Sunday, right? Yep. So, yep. Have a good day. Yep. Yep. Bye.